Hello, everyone. Thank you for joining us today for our ALS Webinar Wednesday series. My name is Malia Forbes. I am a marketing coordinator for ALS North America, and I'll be facilitating the webinar today. Before we begin the presentation, I have a few helpful notes. If you are having technical issues with our webinar platform, you can type a message in the bottom right-hand corner of your screen in the chat pod, and I will assist you. You can also select the raise your hand icon to notify me of your status. All questions regarding the webinar material will be answered at the end of the presentation. Our presenter today is Ron Martino. Ron Martino is the Regional Account Manager of the ALS Laboratory in Houston, Texas. Ron holds a Bachelor of Science in Chemistry and has worked in the environmental laboratory field for over 30 years. He has performed a variety of environmental analysis, served as both a technical director and as a lab director before moving to his current role. Ron has been with ALS as Regional Account Manager for 2 years. Today, Ron will be discussing PFOS method differences and state requirements. Ron, thanks for taking the time to deliver this presentation. I will now turn it over to you.
Thank you, Malia. Good morning, everyone, or good afternoon, depending on which part of the United States you're in. Hopefully, everyone's having a good day, either working from home or working in the office. So what we want to achieve today is, as working in the laboratory, we get a lot of inquiries from our clients on PFAS analysis. And there's a lot of confusion out there because there's a lot of different methodologies. And so our clients are wondering, what method should we be using? So I want to go over some of the differences and similarities. I'll highlight those, the methods, criteria, what the laboratories have to do. Some of it will be redundant from method to method, but there will be some differences that I'll point out. I'll go over some of the compound list, because each of these methods. So we'll take a look at that. We'll look at the method differences, and then once we get done with the methods, we'll look at state regulations. And at this point in time, the regulations are state driven. There's really not much out there on the federal level as US EPA. There is some things out there for the DoD, but they're not regular. DoD doesn't regulate. Only the federal EPA. So most of the regulations, if not all of the regulations, are coming from the state levels. And then we'll look at some of the questions that you may ask yourself, or if you came to me and said, hey, I got to do PFAS analysis, that I will ask of you to determine what method should be used for the analytical that you're trying to achieve, or try to achieve the objectives for your site. So we're going to start with just a little brief chemistry, and we're not going to do a chemistry test or a chemistry indoctrination. What I want just to talk to you about is, what are PFAS compounds? So PFAS is a class of chemicals. It's not one chemical, it's a class of them, similar to like dioxins. Dioxins are a class of chemicals. There are several dioxins that we analyze for, but typically we say dioxins. Same thing for PFAS. So PFAS, there's the class of compounds. When we talk PFAS, we're talking about the entire class, not a specific compound. So they're man-made surfactants that were made in the 50s, and they're used in industry to create other products. So PFAS compounds are not an end product that you would find on the a store shelf. They are used to make the industry, or to make the products that you would use. So some of the products that PFAS was used in making, such as paper products. Paper products, is sandwich bags. People would, for your hamburger, PFAS was used to coat the inner side of that paper. So when you're eating your burger, the grease stays on the inside, doesn't drip through the paper. It's used in nonstick cookware, mainly in Teflon, used in water-repellent clothing and stain-resistant fabrics and carpets. So again, it's not the final product, but it's used in the manufacturing of those products. Also used in the manufacturing of cosmetics. Any product that resists grease, water, or oil. Scotchgard comes to mind. It's used in the creation of Scotchgard. But most of the time when people talk about PFAS, mainly they're talking about AFFF, or aqueous film forming foam, which is used for firefighting. When you have a hydrocarbon that's on fire, they have to use AFFF to put that fire out. It's probably the most common use, especially in the DoD market, in refineries, firefighting facilities, things of that nature. So the main two, or the most common PFOS compounds, are PFOA, or perfluorooctanoic acid, which was used in the making of plastics or fluoropolymers, used in hundreds of manufacturing and industrial applications. It was produced by a number of different companies, and the goal is to have this eliminated from emissions and products by the end of 2015. Unfortunately, that goal was not fulfilled. The second most common one is PFOS, or perfluorooctane sulfonate, which is mainly used in water and stain repellent, and also in firefighting foams. So the major producer was, this one was 3M. They stopped production in 2002, but it's still being produced in overseas producers. However, when this stuff is made, even though PFOA and PFOS are the main two products they were going after, when they made it, there were other PFOS compounds that were also created during that process. The manufacturers, they didn't really care, because those other PFOS compounds held kind of the same properties. They were very, very good surfactants. So it's not a pure product when it went into production, or when it came out of production. And that's why we have multiple PFOS compounds, not just PFOA and not just PFOS. Okay, so the methods that are currently available for the United States EPA, and the ones that I will be discussing. So I'm not going to discuss 537.1, mainly because it has been revised and is an obsolete method. So we're going to talk about 537.1 revision 1. We're going to talk about EPA method 533, and then also 537 modified and then also with the QSM table B15 from the DoD QSM. And then the other methods, the two ASTM methods, 7979, 7968, and the new method that came out from the federal EPA, the 8327. And then we'll also talk about the 8328, even though that's still in draft form and has not been promulgated. And I'm also going to briefly touch about top assay, or total oxidizable precursors. So just a quick overview of these methods, and then we'll get into the details of the methods. And when I get into the details, I'll go fairly quickly. We have 30 slides, and a lot of the information from method to method stays the same. So in 537.1 revision, or the latest 537.1 method that's currently in use, there are 18 compounds, 18 PFOS compounds that we look for. There's 14 PFOS compounds and 4 of the replacement compounds. Of course, PFOS, once started getting determined that it was toxic to human health, then they came up with replacement compounds. They started having the same problems with the replacement compounds that they had with the original PFOS compounds, so we had to start analyzing for those as well. The main matrix for 537.1 revision is drinking water, with the reporting limits of 2 to 40 nanograms per liter. It does not impose isotope dilution and does not follow the DoD QSM. And then going down the list, 533, which is the latest method, came out in December of 2019. Most laboratories are either in the process of getting that online or have got that online. It has 25 compounds, a lot of it being redundant with 537.1. Also for drinking water, the difference is it does do isotope dilution and follows the QSM table B15. EPA 537 modified was the method that laboratories, where they took 537.1 and they modified it to look at multiple matrices. 537.1 was the first method that came out. It was for drinking water only. Well, what do you do with other matrices, such as surface waters, groundwaters, soils, tissues, so on and so forth? So laboratories started modifying 537. And in doing so, the number of compounds is basically unlimited, since it's a modified method. The sample matrices is multiple matrices from aqueous to solids to tissues. Again, the reporting limits are there, and it does follow the isotope dilution. And I'll talk more about the modifications, but at this point, it should be following the QSM B15. Then you have the ASTM 8327, 24 compounds, mainly for waters, drinking water, wastewater, surface water, and groundwater. As you notice, the reporting limits are a little higher than the previous methods and is not isotope dilution or followed the QSM. The same with ASTM D7979. You'll notice that 8327 and 7979 are very, very similar. They basically have the same compounds, look at the same sample matrices, and follow the same procedures. One's just an ASTM method. The other one is the SW846 method. And then ASTM 7968, which complements the 7979, is designed for soil and sludge, again with the 24 compounds. And then, of course, you have the 8328, which is still in draft form, 24 compounds, again, designed to handle multiple matrices, has a target reporting limit. It hasn't really come out yet, and will use isotope dilution and QSM and follow the QSM methodology. Okay, so let's go over 537.1, revision 1.1, which came out in November of 2018. It is for drinking water only. And as I stated, it's for 14 PFOS compounds, the original 14 that came out in 537.1, and they added the 4 replacement chemicals such as Gen X and Adana and the such. I have things here. I'm not going to go over this in detail, just information on the sample containers, the sample storage. You got the holding time of 14 days to extraction and 28 days to analysis. The sample size is used as 25 milliliters and uses a solid phase extraction, and then is concentrated after the extraction. Typical 5-point calibration with continuing calibrations, and quantitates both linear and branch compounds. And as I stated earlier, the reporting limits are from 2 nanograms to 40 nanograms, and the standard batch criteria of 20 samples per batch. So in 533, which came out in December of 2019, this again is for drinking water only. It is designed for 25 PFOS compounds that focuses on short chain PFOS, so carbon chains from 4 to 12. It is not a replacement for 537.1 revision. It complements that methodology. The sample container is the same, but the preservative is different. So when you're talking to the laboratory on 537.1 or 533, be aware that you will need different preservation in your bottles. The sample storage is pretty much the same, but the holding times are different. 28 days to extraction and 28 days to analysis. Sample size is relatively the same at 100 to 250 milliliters, but in this case, it's fortified with isotopically labeled analogs, otherwise known as isotope dilution. If you need to go into more of the isotope dilution, just send Malia a question and we can talk about it after the presentation. Again, solid phase extraction and a concentration step, standard calibration, again, quantitates for both linear and branch compounds, and there are the reporting limits with the standard batch criteria. Now, 537 modified. This is where they took, or where laboratories took the 537.1 and modified it early on to analyze for multiple matrices. So what was happening in the laboratories is, at first we were doing the drinking water analysis, and then our clients started saying, well, what about soils and groundwaters and surface waters? Well, there was no true method out there that was for groundwater, surface water, soil, sludges, or anything of that nature. So laboratories started modifying 537 to accommodate the multiple matrices. They also started modifying it to increase the compound list, because even though the original 537 had 14 compounds, our clients would come back and say, well, what about this one? What about this one? So what happened is the laboratories and all the different laboratories started modifying these methods, but not all modifying them in the same way. So again, you get 4 chemists in the room determining how to modify a method, you're going to get 5 different opinions. So each lab started modifying it, and there was no real focus on meeting the client's objectives. So one lab would do it one way, the other lab would do it the other way. Which one was better? Which one was, did they compare to each other if you went from lab to lab? So what the DoD did is they came out in QSM 5.1, they came out with a table B15. And what it did is it didn't standardize the methods, but it standardized criteria that needed to be met to be DoD certified for 537 modified. So this forced the laboratories to meet these criteria, and in doing so, the methods pretty much got standardized from lab to lab. There may be a little differences here and there, but now it is comparable. Those analyses are comparable from lab to lab because they have to follow the criteria that was laid down by QSM 5.1 table B15. One of the main differences is from lab to lab is what's going to be on your PFAS target list. So each lab, I would say, averages somewhere between 30 and 35 compounds. Some may be a little less, some may be a little more, depending on the project that they're working on. But you're going to get about 30 or 35. This is going to be the largest list of all the methods that we're going to talk about. It followed a lot of the 537 criteria as far as the bottle prep, the preservations. However, we had to make accommodations for soils and tissues if we were going to do those analyses as well. So again, all that criteria came from B15, the extraction, the holding times, things of that nature. So for the waters, 250 milliliters, just like 537, but now 1 gram for soils. It is isotope dilution, which was a modification from the original 537 method. And it was solid phase extraction, typical calibration, again, linear and branch compounds for the for integration purposes and the reporting limits and standard batch criteria. Okay, so then last year, I think it was, method 8327 came out, and this is an SW846 under RECRA. So this basically has 24 compounds designed for water, drinking water, wastewater, surface water, groundwater. So you can see there it kind of follows the same procedures. The only big difference is this method is not solid phase extraction. This method uses what's called direct injection. So the laboratory takes 5 milliliters of water, dilutes it with 5 milliliters of methanol, and that methanol has your surrogates and internal standards in there, and then filters it, and that's it. No concentration step. Typical calibration, typical quantitation for both linear and branch, but because it's direct injection and no concentration step, your reporting limits are typically higher than what you would see in 537, 537, or 533, and of course 537 modified. And again, standard batch criteria. Now the two methods that coming up next, ASTM D7979, 8327 pretty much took ASTM D7979 and almost copied it word for word. So these two methods, 8327 and the ASTM D7979, are essentially almost exact. Holding times may be a little different, but pretty much the procedure's the same. This method is really used in Region 5 of the federal EPA in like the Michigan area, Northwest Michigan, or Michigan and Northwest United States. This method is used mainly more than the 537.1 when it was drinking water only, and used more than the 8327. And of course, the 533 is yet to be determined because that's such a newer method. But essentially, it follows the exact same procedure as the 8327. Or I should say the other way around. 8327 follows D7979 pretty closely. ASTM D7968, again, is specific for Region 5. Obviously, it can be used in other regions, but Region 5 really seems to hone on this one. Has the same compound list as 7979 and 8327, but focuses more on soils and sludges. So you have the sample containers, the sample storage and holding times. In this case, they use 2 grams and do a 10 milliliter addition of methanol water to leach out the PFOS compounds out of the soil. And of course, that methanol water has your surrogates and internal standards, centrifuge, filtered, and again, direct injected on the instrument. So there's no concentration step. Because there's no concentration step, again, you have higher reporting limits because of that. Quantitation is consistent with the other methods, and the standard batch is also consistent with the other methods. All right, so this 8328, which is still in draft form, is going to be the SW846 methodology. Once it comes out, is going to be following under RCRA as well. Follows the 24 compounds that you find in 8327, but also adds Gen X. This method is designed for multiple matrices, where the 8327 method was mainly for water. This method does meet the DoD requirements in the QSM 5.1 table B15. And you'll see there I have sample containers for water, but this is mainly for soils. Your storage, your sample size, 1 gram. This is also isotope dilution. Goes through solid phase extraction, so there is a concentration step. Typical calibration, typical quantitation for linear and branch compounds. And the reporting limit, the target reporting limits are going to be around 10 nanograms per liter. We'll find that out once the method comes out. Once it comes out, after it goes through the edits and reviews. Okay, I do want to, so those are the methodologies to actually do the PFOS. And as you can see, there's multiple methods. Some of them, most of it is redundant, same calibrations, same standards. Sample storage and holding times are a little different. Sample containers are relatively the same. So you really have to determine your matrix and things of that nature to determine which method is going to be best for you. I did want to talk about top assay, or total oxidizable precursors. Each one of the methods that I previously talked about has a list of compounds, some as low as 18, some as high as 537 modified, as the laboratory can fit into their chromatographic run. So in 2012, Erica House and David Sedlak in Berkeley, California, realized that there were over 3,000, some people say 4,000, some people will say higher than that, PFOS compounds. Obviously, a laboratory cannot analyze for 3,000 or 4,000 compounds, and some of them are actually precursors. They're not really true PFOS compounds, they're the precursors. So what TOP was designed to do was oxidize the sample water that we receive in the laboratory to force those precursors to become the PFOS compounds that we can analyze for. So we cannot analyze for the precursors, but we can analyze for their oxidative state. So the lab takes the PFOS, or the samples, which has the PFOS precursors, and we oxidize them with persulfate, sodium hydroxide, and heat for about 8 hours, and it forces those precursors to become the PFOS compounds that we do analyze for. So in theory, what you do is you analyze your sample and you get results. Then you take additional aliquot of the sample and you do the top assay, and you analyze that sample again for PFOS, and you see if your PFOS compounds have increased. If they have, then you know you have other PFOS class of compounds, especially the precursors, in that sample. So you compare the analysis pre-top assay and post-top assay to determine whether you're capturing all the hidden precursors that you're not analyzing for at the first analysis. One of the downsides to this method is you're only going to oxidize the precursors that can be oxidized. So you're not going to get all of them, but you will oxidize the ones that can be oxidized. All right, I'm going to go over these quickly, but this is just the list of compounds. So here's the 537.1 list. There's 18 of them in total. I'm not going to go over each one individually. Here's the list of compounds for the 533. And as you can see, there's more in this list than there is in the 537. But if you compare the 533 to the 537, you will notice that even though there is redundancy in the compound list, there are also some gaps, and there's gaps on both sides. So if you run the 533 method, you'll get the 25 that are X, but you are going to miss the bottom 4. If you run the 537.1 method, you're going to miss that gap in the middle. So which method is to be analyzed is, well, what's your compound list? Just specifically talking about these two methodologies. So to capture all of these compounds, you may need to run both 533 and 537.1. Moving forward, this is just the list for ALS. We do up to 33 PFOS compounds, depending on the laboratory. Some labs go as high as 35. So every state that regulated PFOS compound has their own unique rule, and most do not look for all the PFOS or even the majority of the PFOS compounds. So we essentially took input from our clients on which PFOS compounds that were most common to be used, to be looked for, and created our list accordingly. So if you have a site that you're looking for specific PFOS compounds that's not on any list, you can approach your laboratory to see if they would bring it online using the 537 modified methodology. And the next lists are pretty much redundant because they're all the same list. So here's the 24 compounds for 8327. The same 24 compounds for ASTM D7979 and 7968. And then for the top assay, this is just a graphic that I wanted to throw out there. On the left, there were 4 AFFF foams that were analyzed, and AFFF 1, 2, and 4 barely had any PFOS compounds. AFFF 3 had about 14,000 milligrams per kilogram of PFOS. And I'm not too worried about which PFOS compounds, I'm just looking at the total. Then on these foams, the laboratory performed the top assay and reanalyzed the sample after the oxidation step for the PFOS compounds. And you can now see that a lot of those AFFFs, pretty much all of them, had some sort of precursor that was oxidized into a PFOS compounds that the laboratory could analyze for. So a pretty good size increase from almost nothing to 2,000 or about 1,500 milligram per kilogram for AFFF 1, 2. 4 increased probably the most, almost about 5,000 milligram per kilogram. And you notice AFFF 3 went from 14,000 or a little less than 14,000 to a little over 18,000. So when you're designing your analytical process to analyze for PFOS, looking at the top assay to determine if you have hidden mass or you have those precursors in your waters or soils to be able to better quantitate how much actual PFOS compounds you have in those samples. All right, so now we'll get into regulations. And at this point, and things are moving fast when it comes to the regulations, you could pretty much read articles almost every day about how some sort of regulation has changed, or a new site has been found, new water source, or like I said, I look at this stuff almost every day, and it seems to be changing very, very rapidly. So as it stands right now, most regulations are state-driven. There's very little, if any, federal or U.S. federal-driven regulations. So in May of 2016, the EPA issued a drinking water health advisory for 2 PFOS compounds. Actually, that should be PFOS, PFOS. Oh, I do have that. So the PFOS compounds are PFOA and PFOS. And the advisory limit was 70 nanograms per liter. But this limit is non-enforceable. So there were no regulations out there. If you went out and did the analysis and you found anything above 70 nanogram per liter, you're like, okay, we're above the health advisory limit, but what does that mean? There was no teeth, there was no there's no ability to enforce a cleanup. You just basically found you have above 70 nanograms per liter. So after that period, only 16 states have promulgated drinking water standards for PFOA and PFOS. So not every state has a regulations. So this is just a graphic, and you'll see the states that are in orange basically have adopted the standard below the health advisory limit of 70 parts per trillion. The states are in blue basically are at the 70 part per trillion standard health advisory limit. States that are red are typically above the 70 part per trillion, and all the gray states have not regulated any PFOS compounds in drinking water. So as you can see, there's not many states out there that have a regulation that you have to be aware of. But each one of those states, those regulations are different from state to state. So you need to be aware of that as well. And unfortunately, I couldn't get all of this onto one table, so it's going to be multiple slides. But here are just some of the regulatory types of regulations from state to state. So you have concentration levels, like the first one, New York, at 10 parts per trillion, which is well below the 70 part per trillion health advisory limit, but only for PFOA and PFOS. And then you go up the concentration level. So if you look at New Hampshire, it's 11 parts per trillion for PFNA and 12 parts per trillion for PFOA. So what these tables are basically telling you, and if you go down again to California and New Jersey, they're at 13 and 14, again, for different PFOS compounds. So the reason for these slides, and I don't recommend that you try to memorize this as I go through it, or try to follow along. It's just wanting to show you that even though the states have come out with regulations, each state has come out with different regulations. So for example, in Massachusetts, where the concentration level is 70 part per trillion, where that's the health advisory limits, it's a combined concentration level of 5 PFOS compounds. So if you have 70 parts per trillion of PFOA, you're over the concentration level. But if you have, of those 5 that are in that box and the type of regulation for Massachusetts, the addition of all of the concentrations that you find are above 70 parts per trillion. You also have to follow you are considered over the concentration level. So you have to understand each state when you're working in that state. And that's one of the highest or biggest confusion at this point. If you're doing a job in New Jersey and you're doing a job in Massachusetts, you are following 2 different regulatory bodies at that time. And then moving on to the last slide in regulations. So North Carolina basically only has guidance for Gen X. Not any other PFOS compounds. And then, of course, there are the states with no regulation at all. So that's the regulations on the state-driven side. Again, those slides were pretty small in print, and I just wanted to really show it to you to help you understand that not every state has the regulations, and the ones that do, they're different from state to state to state. And that pretty much gets us to the federal. So what is the federal government doing? So at this point, there's no true federal regulations, but they are trying to implement some things. So this is as of March of 2019. So they're wanting to list PFOA and PFOS as a hazardous substance in groundwater. They're trying to develop interim cleanup recommendations for groundwater, developing the test methods. Obviously, they've already developed 8327, and now they're working on developing 8328 for multiple matrices. For 8327, it's basically just water at this point. Proposed national MCLs. Again, you go state to state, you're at different MCLs. The feds want to come in and standardize that to make sure that if you're in one state, you're doing the same work as if you're doing in another state. Adding more PFAS compounds to the UCMR when UCMR 5 comes up. There were no PFAS compounds in UCMR 4, and I think there were only 6 compounds when they were doing UCMR 3. And then, of course, the final couple of things, development of CW34A, 304A for ambient water quality for human health, finalizing toxicity assessments to characterize potential public health risks, issue significant new use rule, SNR under TSCA, and then considering adding PFAS to the toxic release inventory, or if there's a release, it has to be reported. Okay, so we went over some state regulations and how I said that every state, or not every state, but the states that have regulations, those regulations are different. Some are the same, but majority of them are different. It's the same thing with state certifications. I apologize for this being so small. I just wanted to get it all on one slide so you can see that some states require state certification, not for every method, just for some methods. Some states require NELAP certification only, and other states have no certification process whatsoever. So again, when you are working in a certain state, and let's say Nevada, if you're working in Nevada, you will notice that you have to be state certified, or the lab you use has to be state certified for solids and non-potable waters using 537 modified, but for drinking water, you have to use 537. But Nevada does not have any regulations. So even though the lab has to be certified within that state, there are no regulatory guidelines for that state. So these are some of the things that you need to be aware of when you're designing your analytical program. What state are you in? Because you will have to find out if that state certifies for the methods that you want to use, or if they don't, then the methods they do certify for, or if there's no certification at all, maybe they're a NELAP state, maybe they have a specific state certification. You're looking at like Montana, they only certify for drinking water. So if you're doing a groundwater, surface water, soil, there's no certification for that. California for solids and non-potable waters, strict QSM 5.1. So you're essentially doing DoD methodologies, which is 537 modified at that point. But for drinking water, you got to do 537.1, and California has regulatory guidance that you have to follow. So as you can see, this could get pretty confusing. These are all things you want to consider before you start going out into the field. All right, so the biggest question I get when I'm talking PFAS with clients is, well, what method do I use? The last conversation I had, I think, not the last conversation, but I had a conversation in January where someone came out and said, well, what about that new method, 533? Isn't that a replacement for 537? It's like, no, it's not. It complements 537. It's not a replacement. Oh, well, which one do I use? Well, that's a good question. And at that point, back in January, I really didn't have an answer. So if I get the question, what method should I use? Really what I'm going to do is I'm going to start asking you questions to meet the objectives of what you need to have done. So what state are you in? Do they have state regulations or do they have state certifications? Is this site DoD, or does it have to follow the QSM table B15 like California does? It may not be a DoD site, but you have to follow the QSM table B15. What matrices do you have? Is it drinking water, groundwater, surface water, sludge, soil, tissues? If it's drinking water, you can go one direction. If it's a soil, you got to go a different direction. Again, we noticed, I went through them quickly, but what's your target compound list? Do you have an extraordinary long list that's not covered by a specific method? That may determine what methods you need. Do you need isotopic dilution? Kind of a redundant question. If you're using QSM, if you need to do QSM, you're doing isotopic dilution. And then, of course, what are your action levels? And the reason I said, what are your action levels? And I put this little box down here. This was a project we did here in Texas, and it was for some water. And we were analyzing for PFOS compounds, specifically the 3 PFOS compounds that you see there. And in talking to the client, he was unsure of what method to use. So the regulator actually came back and said, I want you to use 2 methods on the same sample. I want to use 537.1 modified, and I want to use the new method 8327. Of course, the 537.1 modified is solid phase extraction with a concentration step, isotope dilution. 8327, direct injection, no concentration, no isotope dilution. My assumption was they wanted to compare and contrast the methodologies for the results. But there's some things we need to consider at this point. So if you compare these results, and I want to do the bottom section where the analyte name. So we looked for PFHXS, PFOS, and PFOA using 537.1 modified, and we got the results: 73 for PFHXS, 340 for PFOS, and 13 for PFOA. And then we ran it by 8327, different methodology, and you can look in that table. It's pretty close. We got really good numbers, comparable numbers between those 2 methods. So we know those 2 methods can analyze, and you're going to get comparable results. Where you're going to have an issue is when you get down lower in the reporting limits. In the top half of that box, you can see we analyzed for the same 3 compounds using 2 different methods. And using 537.1 modified, we found trace amounts: 6.3, 15, 2.6, which is J valued below the method reporting limits. But if you look in 8327, 2 of the compounds were non-detect. They were simply just below the reporting limit and at non-detect. So where it was above the reporting limit for PFOS, in 8327, we got 16. In 537 modified, we got 15. But you notice PFHXS and PFOA were non-detect. So if you used 8327 only, you're going to say, oh, we're below this level, or we're clean. Well, you may be clean, but you have to make sure you're below your action levels if it is regulated by that state. So, of course, I got to put in this slide. So at ALS, we currently have 3 labs within our network that performs PFOS analysis: Kelso, Washington, Houston, Texas, and Holland, Michigan. We cover all of the methods, not in every lab, but between the 3 labs, we cover all the methods that have been discussed here today that actually are promulgated and being used in the environmental industry at this point. And we do all the matrices that we've been discussing: non-potable waters, drinking water, soil solids, tissues, and we also analyze for AFFF. And between the 3 labs, our combined capacity is about 100 samples per day. So that pretty much is the end of the presentation. If you had any questions, I think you're supposed to type them, and Malia was going to bring those questions to me. This is my contact information if you want to reach out to me directly and have a discussion. Other than that, Malia, I'll turn it back over to you. Hopefully I didn't confuse or go over it too fast, or confuse everybody or go over it too fast. So
thank you so much, Ron. We will now open up the forum for questions. Please write out your question in the chat section at the bottom right, and I will give everyone a few moments to get their question typed out. I'll give some brief news. The webinar presentation has been recorded. All participants of the webinar will receive a follow-up email once the recording is available for view. We also post our webinars on our ALS Global website and our ALS YouTube channel. I encourage you to find a wide range of video resources and past Webinar Wednesday presentations available there. Also, please follow our showcase page on LinkedIn as we post announcements and registration links to future webinars and other valuable resources and updates. I'll give everyone just a few more minutes to type out a question. Well, Ron, I think you did a very thorough presentation. I don't see any questions at this time.
Well, it was either thorough or confusing.
I'm going to go with thorough. Okay, we thank everyone for attending today. Enjoy the rest of your week.